Hi, today I will present you how to connect a pump and a fan to the Raspberry Pi or CM4 board through a module with relays. You can connect up to 16 devices to Raspberry Pi or CM4 board. How? If you will buy two modules with 8 relays per module, you will be able to do that. So now I'm going to present you how I did it. Here you can see the whole configuration. Power source, the cable, connection, minus the black one, and plus the red one. Here, the red one and the black one. You can see it exactly. And from here, 3 red cables, and here 3 black. 1, 2, 3. And so black to the fan and red to the fan, and it goes here to the relay. Red for the pump goes to the relay. Black for the pump goes here. Black for the power source goes here to the ground, and red to the power source goes to the JD VCC, and VCC goes to the 5V to the CM4 board or Raspberry Pi, and white and blue cables goes to the in 1 and 2, pin 13 and pin 12 into the CM4 board or Raspberry Pi GPIO pinout. Have to be checked, and you can connect it to the GPIO pin, those blue and also this red one. 5V, pin number white, pin number 12, blue, pin number 13. That is all actually, and this is the whole setup. Here you can see a power source, this one, and there is a white cable here, and you can see I soldered it here, so they are connected this way. And this is the red, the plus, and the black, the minus. So now it divided to 3 cables, and one red goes to the, and give me a moment, goes to the module, and it's connected to the JD VCC. The other 2 goes to the relays, 2 gates, and from the pump and from the fan, red cables goes also to relays, and 1 red goes to 5V to CM4 board, and white and blue go to the pin number 12 and number 13. It's in 1 and in 2, so I can control the relay. And then also you need to understand the minus from the pump goes here, and minus from the fan also goes to the black one. So all is connected properly. And now we will see this in action. So I will try to connect the relay and you will see how it is working. So first of all, what we need to do, we need to switch to the command line. Here we go. We have our connection already presented, and I have a script inside this relay.py, and I will show you how I did it. So in the beginning you have something like GPIO set mode, and you are importing the GPIO as GPIO, so you're getting the main GPIO libraries error. And I will, by the way, I will correct it to library here, and then you're getting the time library, and setting a current mode, removing the warnings. Then you're creating a list, an array actually, with the number of GPIOs that we are using, and in this case pins number 12 and 13 in 1 and in 2 on the module with relays. And then we are setting the mode for all pins, so all will be switched on. And for loop where pin equals 12 then 13, We are setting the GPIO to high or 1 or 2, and you can see how I did it. GPIO high, sleep, GPIO low, sleep, and then we are checking if the current relay is running and printing it. So we are checking are those pins working correctly, and the same, but the difference is that we have for loop where pin is a backward, so it's running backwards. So also high, sleep, low, sleep, and at the end there is a cleanup. So I'm going to run it now. Python 3 relay, and you should be able to see it on the screen. And now GPIO goes high, so you should, I will try to put it closer, and you should see LEDs here. And now the LED is blinking. Excellent, it is working as expected. So it turns on and turns off pump and a fan. So it's not a big deal. So I will try to present that the fan is working. I'm not sure it. You should be able to see it now. And this way, I will run once again the command line, and you will see the result. Here we go. And now this one is blinking, and the second is on now. You can see it. And you can see the fan is working, and I see also the pump is working as expected. So there is no problem with this configuration at all. Now the pump is off, the fan is still working. No, the reverse rate. Now the fan is working, and it's off. I'm going to present on the command line. So here you have the whole configuration, and you can see how the script is working exactly. I did exactly the same configuration for the Raspberry Pi previously, before I decided that I will solder those wires. So now you can see the final result, how it will be working in the future, because what I'm going to do is to write a script in Python that will behave like the temperature goes above 40 or 50 degrees, then the water pump and a fan will turn on, and let's say below 30 degrees of Celsius or 25, pump and fan will just turn off. And that's something that I'm going to do, and I will also share the script with you in the future. But I would like to present you how I did it with Raspberry Pi, and it was much more difficult because it was my first try and it was a prototype, so you have to be very patient, and some parts will be speeded up just to not wasting your time anymore. This is the whole connection. Water pump 5 volts, fan 5 volts and 3.3 volts, of course, both, and proper connection to the module with 2 relays, and also the connection goes to the Raspberry Pi 4B, and that is all. The whole schema is here, so you can see it on the screen. One thing is worth to mention, I will talk about this jumper hat. I removed it to isolate the power supply and fan and pump from the Raspberry Pi. So just like that. Relay to channel module with opto isolation. 10 amperes, 250 VAC contacts, 5V coil. So the module has two relays SRD05 with a coil powered with a voltage of 5 volts with optical isolation of input and mounting holes. The system allows you to control the actuators with microcontroller ports or with an implementation set. And this way you can connect it, and here you have the schema, so you can see it how it looks like. And yeah, we have a JD VCC, VCC and GND, and here you have VCC, ion 1, ion 2, GND. So minus and minus goes here, and plus goes here and here and here. And it doesn't matter. So first of all, from the power supply, external power supply, you connect plus here, the red one, the red wire here to the JD VCC, the black wire, the minus to the ground, the GND, and then the plus from the Raspberry Pi to VCC here or VCC here, then control PWM pins to in1 and in2, and the ground is empty. So you can connect the ground to the Raspberry Pi, but you don't need it. It will be working like that. So the system is isolated this way. And if you are using external connection. So now I will switch to the root user because I have the configuration there, and cd pwm, and inside this I have a relay directory, and inside this I have a script relay.py. It's a Python script, and I will try to explain how it is working. So in the beginning you can see we are importing RPI GPIO, and after that there are commands setting a current mode, removing the warnings, creating a list of array with the number of GPIOs that we use, so pins 12 and 13. Now I will switch for a moment to the GPIO, and we will see this is schema, and this is the GPIO pinout, and here we can see pins number 13 and number 12, PWM0, this one, and PWM1. So I connected 12 and 13. Okay, now you understand how we are working. So if you want to add more, for example, if you have a module with 4 relays, then you can use more pins to control it. For example, GPIO 18 PCM clock, you can use this one, or GPIO 17 if you wish. It depends on your needs actually, so you decide which pin to use to control. Of course, not every pins you can use, but it's not a problem. Here you have PCMD out, PCMD, PWM0, yes, and PWM1, and here we have SPI no, but PCM is fine. 17, 18 is okay, even 27, 22 should be working correctly. So let's go back to the command line and we will see what is going on there. Okay, so the next thing is to set the mode for all pins, so all will be switched on. Then we are creating a loop for a loop where pin 12 and then next 13. And we are setting the GPIO to high or 1 or 2. Then we wait 5 seconds and we then set the GPIO to low or 0 or false. Wait next 5 seconds. Then we are checking if the current relay is running and printing it. So that's the way we can do it. And at the end, same, but difference is that we have for loop where pin 12 next 13 backwards. So this is working backward. And then the same thing, so reversed and 5 seconds of sleep. And after that, GPIO cleanup and shutdown of relays. This script is working this way. This is a test script to see if the connecting device are those devices that are connecting properly for the relay, and is it working as expected. So we will try to run it Python.screen relay py, and we should be able to see this. fan is working. And now the pump is working too. Excellent. Lovely. And the result is achieved. Excellent. So everything is working as expected. So this is the final version, and you can see the result on the screen, how I actually did it. So here is the transparent pipe, and there are wires inside these transparent pipes, and these transparent pipes goes outside, and here goes the wire to the power source, and you can it is connected there. So I'm going to present it in a moment, and you will be able to see it. Here we go, like that. It is connected, so you can see how it looks like. And now we are going to test our environment, so you will be able to see that it is working as expected, and everything is perfectly fine. So this one, I will try to do this way, just because we want to see the fan, that the fan is working. Okay, maybe this way, something like that. And now I'm going to connect the command line for a moment, and I will run the Python script, and you can see it is running, and I will switch to the camera, and you will see the result. So you can see blinks, and now the fan stopped, and I will just move a little bit this one, and now you can see the fan is working, and the pump is working all the time, and I can hear it. And now fan stopped, now fan starts, now the pump should stop. Yeah, it stopped. Now it's working, and fan is working all the time, you can see. And now both are off. So you will see the result on the command line, and here we go. You can see this. It's really easy to understand it. So first there is a GPIO high, then sleep 5 seconds, GPIO low, sleeps 5 seconds, pin 12 is working, right? So it tested pin 12, then GPIO high, sleeps 5 seconds, GPIO low, sleeps 5 seconds, and it checks that pin 13 is working, and now backwards. So GPIO high, sleep 5 seconds, GPIO low, and sleep. And one more time, GPIO high, sleep, GPIO low, sleep, GPIO cleanup, and shut down. So backward, it means that in the beginning it tests pin number 13, and then it tests pin number 12. So this is the whole idea of the script, to make it work and check is it everything working as expected, and that's how it looks like. So I hope this time everything will be inside this case. I know it looks like a little bit messy because it's a pasta, but not so bad in my opinion. Eventually I will try to figure out is there any possibility to put those wires into the transparent acrylic pipe and to make it work to look better. I would like to put RGB LED inside the pipe, and if there will be a possibility to put those wires into the pipe, so I could have 2 LEDs inside the case, and it would like to I would like to do that, and to make it more, let's say, fancy, and to make it look nice at night, because I work often at night, so I would like to have something like that, to have LEDs inside the case and to see how the result will look like. I think that I will use green, red, and blue, and maybe white LED, something like multicolor LED, but mostly I will use those 4 colors and I will try to mix it. And I hope the final result with LEDs will be nice, but I'm not sure will I be able to put the LED inside of this pipe. Eventually, if not, I will put a separate a pipe with LED into the case without wires inside. So I will just try and I will figure it out. Is it possible to make it work the way I want? And then I will probably record a new separate video about this. So I hope that now you will see that the connection is working properly. Everything looks quite good in my opinion, and it's working as expected. There were 2 issues actually with the Raspberry Pi during the prototyping it. The first one was that if I connected to 3.3 and 5 volts, I connected pump and I connected then the fan and were testing it, and after that I connected 3.3 fan and 5 volts fan, 2 additional fans to the GPIO in the Raspberry Pi. There was a problem. When I connected 3.3, my monitor went black. That is normal, and this is a normal behavior. This is because of the lack of the voltage. It's under voltage actually. So you need to provide more power. Just because I'm using a SSD with a separate power source, that is okay, and it should be done like that. And I also connected 2 additional fans to the GPIO pins, so Raspberry Pi didn't have a proper amount of power, and there was an under voltage. And I'm going to also investigate it in the future, because you can actually run the VGCNB command, if I remember correctly, and exactly see is it throttling or not, and if you have an under voltage or not. Raspberry will show you this on the command line, and that it's very convenient thing that you can use to actually perform a check. And the second problem appeared when I connected the second, actually a 4th fan to the GPIO pin and to the 5 volts, and then the operating system, actually the file system, went into read-only mode. And this is also a normal behavior, because when you have a throttling, the system goes into the read-only mode. It's a normal behavior of the Linux system, and to protect the operating system, and this is something that is very good. However, you need to remember to shut down the system immediately after that, just because to avoid any problem. It's not very safe if you are using SD card, because it can be broken. So because I'm using NVMe in my CM4 board and I'm using SSD in my Raspberry Pi, there's not a problem for me. And also I have backup. But you need to remember about this, and if you are using SD card, be prepared that SD card can be damaged. So it's good to have a secondary SD card with a backup of the operating system there. And actually that is all, because what you need to do, you need to have a multimeter, you need to measure it. Eventually you can use a command line and proper commands to measure the under voltage and the throttling, and you can check is it everything working as expected. However, multimeter is better, because if you will check every single place where you have a proper voltage and is it okay or not, and the resistance and everything can be checked, then you will be able to exactly know where the problem is located, and is it a power source or is it something else, and you can eventually fix it. Okay, I hope you enjoyed this video. So thank you very much and have a nice day. Take care. Bye bye.